My name's Ian. I'm an engineer. I've done some business. I'm a dad, and I've been, kind of quite worried about climate change until fairly recently. Um, I started to learn about what people were doing using this molecule right here. So this is nitrogen and hydrogen. The air is 78% nitrogen, so nitrogen's easy to get, and hydrogen you can get from electrolysis, cracking water. So this molecule is pretty easy to make with green power, and it's really useful. So this is ammonia. And today we actually consume a ton of ammonia. Ammonia is used um, a lot in uh, fertilizer. So I came across this person running a farm. I'm going to tell you about it, but it got me thinking. What is the actual greenhouse gas consumed to put food on the table? So I'm not talking about cow farts. I'm talking about like fertilizer and gas and grain drying. How much greenhouse gas goes into that sort of stuff? And part of the reason why I want to think about that is this, like drying, tractors, fertilizer. All of this stuff probably isn't going to be done with batteries. Batteries are definitely not going to be fertilizer, probably not tractors, unlikely to be grain drying. So that means, our food system is still going to contribute a lot of bad stuff to climate change. Um, so I looked up some numbers. This is from Manitoba, all right, which is a province in Canada. It's for wheat. So obviously, rice or apples or oranges is going to be different, but just as a sample, uh, so a farm has its operating costs, and then it's got its total costs. Um, but let's look at both. So fertilizer for wheat is 37% of the operating or 20% of the total. That's a lot of greenhouse gas, right? That's a lot. Fuel, 11%. Driving those tractors, they're pushing dirt. That takes a lot of energy. Drying, another 5%. That's when you think about the scale of the industry, that's not insignificant, right? And of course, none of this includes like the truck that takes the wheat to the bakery, right? No, like there's a lot of other greenhouse gas before it hits your table, but this is just at the farm to produce the wheat, right? So came across this interesting project run by these two guys. One was a NASA engineer, propulsion lab, 52 years. Pretty smart guy. His buddy, system design engineer, has done a lot of other really neat projects. And they have this farm um, set up a couple years ago with the mission to implement an entirely carbon-free farm, right? So, and the thinking behind this is sort of twofold. One, uh, looking out in the future, and I guess if you stare at planets every day, you get used to thinking about things in a different time horizon. 300 years from now, if we don't have any oil, I mean, that's a main component in a lot of pesticides, insecticides. So what we're using in our car today or in our tractor, uh, a couple hundred years from now will be really valuable if they're running out of food, right? And the second thing was to be emission free, to see if they could do it as a demo to other people, because they, like me, are quite concerned about climate change, right? The effect all these greenhouse gases are having. So the ammonia that's used in fertilizer is to this time, like the new stuff is coming online, but for the past 100 years, it's been this stuff. They take natural gas, they break it apart and create carbon dioxide, which goes off into the air, right? Greenhouse gas. Take the hydrogen and combine that with the nitrogen out of the air to create ammonia, right? So that's where it comes from. And they're going to do it in a different way. So they're going to use green electricity, break apart water to get hydrogen, and combine that with air to have nitrogen. So they are using both hydrogen and ammonia. So here they on their website, which is in my notes, you have the solar. You take the direct current and turn it into alternating current because that's what their hydrogen generator uses. The hydrogen generator is going to break down water into oxygen, which they vent, and hydrogen. And there are different technologies that do this. This one is using a proton exchange membrane. And I don't know what's best, honestly. Like, there's a trade-off between cost, efficiency, can it handle variable energy, maintenance, but they're using proton exchange. So then they have this compressed hydrogen, and they take nitrogen out of the air and compress it as well. So we have these bottles of compressed gas, and they combine them in the red tanks. And inside there is an electronically heated catalyst. So that catalyst makes the hydrogen and nitrogen react and combine together. So then out of that, you have ammonia, right? So hydrogen, ammonia. They store some hydrogen, they store some ammonia in tanks. It's pretty safe. It's kind of not a big deal. Now, then they use hydrogen and ammonia to run this tractor, right? So the tractor, initially, they planned on using hydrogen because, for how many years have people been talking about hydrogen as a fuel? But as they were trying to do this, they figured out hydrogen and ammonia combined is far better. So basically, the ammonia, its storability, its safety, the engine performance differences, the whole thing, it's significantly better if it's mostly ammonia. Now, in this setup, in this tractor, using this engine timing, the hydrogen helps, it's like an accelerant. It helps the combustion snap. So that's why they have a mix. But I think it's, maybe my next slide says it. I think it's 80-20, 90-10, something like that. It's mostly ammonia. And if you're curious, like, they will license this tractor technology for you. Here's a summary of what they changed. So a regular fuel injector will leak hydrogen. So they put in some high performance injectors for the hydrogen side. They add some extra injectors to the engine throttle body for the ammonia. And then they have a second ECU because they are feeding two fuel sources, and one ECU doesn't do that. But basically, what do you need to change in a tractor? I mean, it's not crazy. You can just make a tractor work on this. They'll teach you how. And that's really cool, right? So why ammonia versus battery or fuel cell? In summary, why is this important to know about, right? And this is from them. This is taken from a presentation. Again, I'll share it in the notes. But their take is this: the long-term viability of battery and fuel cell power equipment is just They don't see it. It's not apparent. So batteries, there's insufficient materials for 100 million vehicles. There just isn't enough lithium and stuff to do this. It cannot scale that big according to the numbers they're seeing, right? Similar, the availability of electrical power. Electrical power is like 25% of the power we use in North America. 75% is fuel. So that's a huge increase in the amount of electrical power to do this. And again, tractors run 12 hours a day. Like they're not, it's not the same as a little commuter car, right? The need for electrical infrastructure or hydrogen infrastructure for gas storage for millions of vehicles. Hydrogen, again, these are the guys handling it, is just, it's more difficult, it's less safe than ammonia. Fuel cells, batteries, winter performance is really limited. And fuel cells, again, what they have seen is the lifespan is limited. You know, I've worked on farms where the tractors were like 50 years old. You know, they are designed to go and go and go. And a fuel cell that doesn't last is probably not what farmers are interested in. And finally, hydrogen is so tiny, it's so minuscule that it leaks, right? You know, these guys are dealing with it in their injectors, but in everything they do, there's hydrogen leaks. So, you know, their sheds that make the hydrogen have to have special venting, etc., because it's so small, it gets through everything. So there you go. There you go. Ammonia is this really interesting thing that farms could be 100% greenhouse gas free, right? Free. And you know, their own solar, their own whatever, or farming cooperatives, you know, you do it together, you borrow some ammonia off your neighbor, you know, you pay him back next week, whatever. But it's it's really interesting that people are out there doing this, that it works, that it's not, yeah, okay, they are NASA scientists, but it's not billions of dollars of research, right? These are two guys on a farm, two guys on a farm, right? Like, and so anyway, that's I was in a bad mood about climate change, and now seeing what people are doing, um, I think solutions are really here and available. All right, take care.